So far, all of the indeterminate types that we've looked at have been the type 0 over 0 or infinity over infinity. There are other indeterminate types that we have to consider. That is 0 times infinity, infinity minus infinity. We're going to look at those next two types now. In any case, we want to manipulate these so that we can get them into the L'Hopital's rule form, which is 0 over 0 or infinity over infinity. So the first example is the limit as x approaches 0 from the right of x times the ln of x. So this is the form of 0 times negative infinity, which is the same as 0 times infinity. It's indeterminate, and we need to rearrange this, manipulate this algebraically to get it to be 0 over 0 or infinity over infinity. So the way we typically do that is we pick one of these two pieces of the product and we bring it to the denominator. You should consider which one is going to be easier to take a derivative of. Since the x is a power function, it's going to be easier to take a derivative of if we bring it to the denominator. You can bring it to the denominator by giving it a -1 power, and now when we think about this top function, we're thinking about the ln of x. As x approaches 0 from the right, we see it's going to negative infinity, and 1 over x, we know that function looks like this, and as x approaches 0 from the right, it's going to positive infinity. So this is a infinity over infinity type of indeterminate form, which we can use L'Hopital's rule. Derivative of the top function is 1 over x. The derivative of the bottom function is negative x to the -2. Let's rewrite this algebraically. So we have x to the -1 divided by x to the -2. Rewriting that gives us negative x to the -1 plus 2, which is just x to the positive 1. And now we can use the direct substitution property, and we have 0, -0, which is the same as 0.